first thing we want to do is we want to load our data, and I've got to read the problem because it's going to tell me essentially what X and Y is. As you'll find sometimes in economics problems, they reverse X and Y. Or they ask you to reverse X and Y. So somewhere along the line it'll tell me essentially what X is and what Y is. The following data represents the weight in grams of a box of raisins and the number of raisins in the box. And it says, does the function defined by the ordered pair Wn, now that says the W is our X value for all intents and purposes, and N is the Y value, because W is in the first position and N is in the second. So that tells me what X and Y are. And so that says, is it a function? Well, if it is a function, that means that what can't I have in the X column? Repeated X's with different Y values. So 42.3. Here's two 42.3s. One is an 87, one is an 82. So 42.3 goes to how many places? Two. So it cannot be a function.
Oh, okay.
So does it represent a function? The answer to that one is no. And then it says, then draw a scatter diagram of the data. We're going to kind of leave that till last. The only time I'm going to ask you to draw a scatter diagram, by the way, is not on your calculator, but is on paper. Calculator is going to drive you crazy. And then it says, select 2 points and find the equation of the line containing those 2 points. And then it says, graph the line on the scatter diagram, express the relationship found using function notation, predict the number of raisins in the box, interpret the slope of the line found. So let's start with the first part down here at the bottom and define the input and the output variable. And the input variable, they say, is W. And the units is, well, it's the weight, and the weight is in what units? Grams. Okay, and then what we're looking at is the weight, I, a box of raisins. And the output variable is N. Now my calculator is going to call it X and Y, because that's all it operates in. It operates in X's and Y's. And the output units is raisins, because it says number of raisins. So it will be 10 raisins, 30 raisins. So the output units would be raisins. And what is it? It's the number of raisins in the box. So we now know what X and Y is. And by the way, if we were to think about a slope, and the slope is the change in Y over the change in X, because delta means change, the units would be Y is in raisins, and X is in grams, and so it's raisins per gram. Raisins per gram. So I would say for every additional so many grams in weight, the number of raisins either increase or decrease by that number. And we did say this is not a function. So before we leave this page, let's get the data loaded into our calculator, because we'll go to the next page and it's going to ask a series of questions. And and the TI-84, TI-83 operate the same way. Doesn't matter whether you got the color, whether or not you don't have the color, they all operate the same way. So I would look at the second row, third column. There's the word stat, and I guess I have to turn it on. That would be helpful. And notice it's got the same thing. Do I want to edit? Do I want to sort? Ascending, descending. This clears a column. Setup editor, if you ever lose your L's, that's what you're going to be looking at. And I do want to edit. And now I need to type in my information. And so the X's go in first, 42.3, 42.7, 42.8, 42.4, 42.6. It won't be too long. I'm going to come in with my stuff preloaded. 42.4, 42.6, 42.4, 42.3, 42.5, 42.7, and there's another 42.5. And then I go back up to the top. I've got data in there, so I'll just type over top of that data. And 87, 91, 93, 87, 89, 90, 82, 86, 86, 86. And then I make sure that these guys are at the same level, that I haven't made a mistake, which I often do. So that's my first cross check, and hopefully I have typed it in correctly, not incorrectly, but put it in right. Let's try it that way. Okay, so now we're going to be ready to go for the next page. Now, I'm not going to do the scatter diagram. We're going to skip that, and we're going to move on to the next question, which says, select 2 points and find the equation of the line joining those 2 points. And that says I'm going to go back to my data, and I'm going to pick 2 of them. I don't know. I'll pick the first and the last. Just as good as any. Top and the bottom. And the 2 points I'm going to do is the first one, which is 42.3, 87, and 42.5, 86. And it says, find the equation of the line containing those 2 points. Well, if I need the equation of the line, I need the slope, I need a point. And it doesn't matter which point I use. I'll just pick one of them. Now I need to find the slope. And the slope is found using our old furry friend, the slope formula. Change in y, 86 minus 87, divided by change in x, 42.5 minus 42.3. which is a negative 1 over 0.2, which is a negative 1 divided by 0.2, gives me a negative 5. Already, this does not make sense. Why does this not make sense? Remember, this is over 1. This is weight. This is no. This is. Oh, I already forgot what the y value is. Y value is raisins. over grams. So what is this saying? This is saying for every additional gram, what happens? The number of raisins decline by, does that make sense? I could get smaller raisins. I mean, I don't know. But it doesn't make sense. But we're going to do it anyway because who cares? We're going to do a, and it says, well, if I want to find the equation of the line, I know that now the slope is -5, which doesn't make any sense, but that's okay. So this says that y minus y1, which is 86, equals m times x minus x1, which is 42.5, and m is -5. Or y minus 86 equals -5x plus, and 42.5 times 5 is 212.5. And then I'm going to add 86 to that. Or my equation is going to end up being y equals -5x plus 298.5. This is a very bad model. That's why linear models, whenever you do them kind of randomly, you have to be very careful. I just picked the wrong 2 points. I just picked the wrong 2 points. Because this says if it weighs nothing, if there are no grams, how many raisins do I have? No, if there are no grams, according to my model, how many raisins do I have? 298.5 raisins. Does that make any sense? No. That is a very bad model. Would I use that to predict the future? No. You get to sign it twice, I think. I'm not sure. I don't remember. And it says graph the line. We'll skip that. Express the relationship found in part C in function notation. This is all they're saying. The relationship I found was y equal -5x plus 298.5. If I'm going to use the x values, this would be f of x equals -5x plus 298.5. That says I'm taking that and writing it in function notation. Now, if I wanted to use the notation the book uses, which is W and N, this becomes N equals -5W plus 298.5. Or this would be N of W is -5W plus 298.5. Now, if I'm writing a computer program, I would probably use N and W because it has meaning to me, right? Because when you're writing computer programs, what begins to happen is that you're going to ask somebody input something. And then that variable basically usually matches what you're having them input. So that's an easy thing to do. On some of the calculators, and not the ones we're using, but some of the more sophisticated calculators, you can actually put it in as N and W in terms of your variables. So it allows you to do that, to create more functions other than X and Y. And then it says, use your model to predict the number of raisins in the box that weighs 42.5. Now, this is what you have to understand. I have two variables. I either put in X and get out Y, or put in Y and get out X. I just need to know, they give me a certain piece of information, I'm looking for the other guy. So you have a 50-50 chance of getting it right. And it says weight, and we know weight is W. And if I look at my formula that has W in it, that's really the X value. So this would say that N is -5 times W, which is 42.5 plus 298.5. This is an exercise in futility because we do know that we have a crappy model. So -5 times 42.5 plus 298.5. And I have to have my calculator on. That would help. -5 times 42.5 plus 298.5. Put it all in at one time, which is kind of nice. And it says, oh, isn't that nice? 85 raisins. So 42.5, 85 raisins. And then we're going to interpret the slope found in part C. Well, that lousy slope, so we know that M is -5, which is -5 over 1. I always find it helpful when I have to interpret as I put the units in. The Y is in raisins, and the X is in grams. And the picture says 1 gram. So add 1 gram. This is a -5 raisins, which we know is silly, but that's where we are. So what do we say? It says for every additional one gram in weight, the number of raisins decrease by 5, which makes no sense. This makes no sense. Or maybe you let the raisins kind of lay out there for a while and dry out, and then they really weigh less, or I don't know. And then it says, use your calculator to find a linear function that best fits this data. Well, we know how to do that, right? So on our calculators, we've got the data loaded. So we go to Stat, second row, third column. And now we've got our data in. We're going to calculate. We want a linear regression, LINREG. Press Enter. And that says, now it's waiting for me to tell it, essentially, who's your X value, who's your Y value. Now, if I were, say, in an economics class where I have year profit, year revenue, I would say maybe it's L1 and L3, or L1 and L4. That says I've got different columns that represent Y values, but the X values stay the same. But in this particular instance, everything is in L1 and L2. By the way, this is useful if you lose your L's for whatever reason. Some of you will. You will delete them, and then we have to figure out a way to get them back. Is that the default is L1 and L2. So if I don't put anything in there, that's the default. For those of you with the, as you saw yesterday with the Keller calculator, it allows you at that point, it says L1, L2, it allows you to change it just in the menu as you head off to do the calculation. And now I just press enter. And there we go. And that's the model itself. And we'll just take it to two decimal places, 11.45 and negative 399.12. So this says that y is equal to 11.45x minus 399.12. And already this doesn't make any sense. Why does this not make any sense? If the weight is 0, how many raisins do I have? A negative number of raisins. Maybe we ate them before we had a chance. I don't know, but it doesn't make any sense. Now, why doesn't it make any sense? Well, take a look at the correlation coefficient. Here's R. R is 0.64083. I usually have you write it to 5 places. With an R of 0.64, how good is this fit? It's horrid, right? It's not even close to 9.9. No. Not even close. So should this thing not make sense? Yeah, that's right. Basically what it's telling me is that overall a linear function is not the fit for this particular model. It might be a different kind of model. So, but a linear it's not. So we know that this is a very bad fit, no matter what we do. Very bad fit.